Hi students, this is Mr. Yao. In this lesson, we're going to continue to learn more about quadratic story problems. We're going to continue to work more with the unit price, unit sold, and revenue, and profit and cost kind of questions. But first, we're going to start with the example 2, since example 1 needs something that we could actually benefit from example 2. So let's have a look at example 2. When we set the price of a ticket as $40, we can sell 350 tickets. For each dollar increase in the price, 5 less tickets will be sold. If the price is $50, what is the total revenue from ticket sales? So let's play with the numbers a bit. So when it says, well, let's write down price, unit sold. When it's priced as $40, it's selling 350 tickets. And then it says each dollar increase 5 less. So that means if it's actually $39, we are going, increase $41, we are going to sell 345 tickets. And when it's $42, we are going to sell 340. So with this way, you can actually go all the way to deduct what exactly is going to be the amount of tickets sold when it's actually $50. So this is changing by 1, and this is actually subtracting 5 on that side. So let's say we actually have 45. That will be a changing by 5. Well, in that case, since each one is corresponding with a -5, if it's a +5, it's going to correspond with a -25. That's going to be selling 325 tickets, which means when it's $50, in that case, it's a +10. On that side, it's going to correspond with a -50. It's going to sell 300 tickets. So for question A, we can at least answer. It's going to be $50 times the 300 because the revenue typically is the price times the unit sold. And it could be a P of X or S of X, whichever it is. But it's 50 times 300 in this case, which is going to be a revenue of $15,000. Part B. What price will result in a total revenue of $14,625? Well, in this question, we have to decide what exactly do we want to pick as our X. Well, here's the thing. Let's say since it's asking for price, let's pretend that we're picking our price as our X, as our variable, which let's say is P. Well, the representation, the relationship is when P is going up by 1, the unit sold is actually going down by -5. So if we actually pick a P, we still need to use this $40. The relationship is going to get quite complicated because it's not just P plus 1. It's actually P comparing to 40 and then plus 1. That's where things will become a bit more complicated. Let's say, for example, the 50, you're going to actually need to figure out, oh, you actually added a 10, and then for the ticket sold is going to be -50 from 350. So that means the relationship is not directly with the price or the unit sold. The actual relationship is built upon the changes in the price and the changes in the unit sold. So in that case, we are going to set our change in price from 40 as our X. Because the change is going to be easier to work on the relationship, since $1 change on the price, which means when X is 1, on this side is going to be -5X. So that's the relationship. So now we can actually write our revenue. The price, we also need to present it, is going to be 40 plus X. Because X is the amount we're changing from 40, so we're going to have to add up on top of 40. And then for the unit sold is also going to be based on 350. Because it's changing from 350. It's 5 less ticket from 350 for each of the dollar change. If it changes X dollars, it's going to be a -5X for the changes in the unit sold. So there you go. That's our actual setup for the revenue equation or function. And what we're trying to find for part B is we're trying to find when is this revenue going to be 14,625. So we're going to set it to 14,625. let's solve it. 40 times 350 is 14,000. And it's plus 350x minus 200x minus 5x squared. Let's subtract the 14,625 over. Okay, we will have negative 5x squared plus 150x, then minus 625. We can take out a GCF, which is negative 5, or in other words, divide everything by a negative 5. We'll have x squared minus 30x plus 125. You can either use quadratic formula or you can factor. In this case, we can factor. It's going to be x minus 25 and x minus 5. So our x could actually be 25 or 5. But remember, our x is the change in price. Our actual price is not just 40. It's what's changed from 40. So we have two options. Our price could either be 40 plus 25, that's one option, which is at 65, or the other price could be 40 plus 5, which is at 45. If you actually want to check, well, for 45, since the change is going to be $25, which means the ticket amount is going to be 350 minus 5 times 25, so it's 350 minus 125. It's going to be 225 tickets sold. When you multiply them together, it is going to be 14,625. Okay, if it's $45, the change is a 5, so it's going to be 350 minus 5 times 5, which is 325 tickets. 325 times 45 is also 14,625. So our answers, $65 or $45 would actually both end up with a total revenue of 14,625. That's example 2. Now, based on that understanding, we are going to go to example 1. A football stadium holds 40,000 fans. Based on past record, if the ticket price is $15, the attendance will average 28,000. If the ticket price is $12, the attendance will average 34,000. So the wording is slightly different. We still have the ticket price, but instead of saying the ticket sold or unit sold, is actually using the word attendance. Doesn't matter. You just have to understand the word attendance is actually representing the unit sold for the ticket sold. Well, because in order for people to attend, they have to buy the tickets. So the attendance corresponds with the amount of tickets sold. Okay, so we still have a P, which is the ticket price, and the S, which is the tickets sold. So the difference between this question and the previous question is, in the previous question, each dollar amount change is already given and with a relationship to the unit sold. For this question, they're not directly given. So let's actually write some numbers down. Price and unit sold. When it's priced at $15, 28,000 tickets sold. When it's priced at $12, it is 34,000 tickets sold. So the 40,000 actually doesn't do anything with this whole question. Now, in order to find the revenue or maximize the revenue in this case, that means we just need to find that relationship between the price change and the ticket sold change. And then we can do the exact same thing. And that's why there's this next sentence. If the attendance is linearly related to the ticket price, which basically means $1 change in the price is going to be corresponding with a certain number amount of ticket sold changes. So as you can see in here, when it actually went down $3, over here, it went up 6,000. Okay, so that means for each -3 of ticket dollar is corresponding with 6,000 extra tickets sold. So if we divide both numbers over -3, which is -2,000 over 1. So this basically means for each dollar amount plus 1 is going to be corresponding with a -2,000 ticket sold changes. So there you go. We actually found this information that we had in the previous question. So now, in order to solve this question, we're still not going to set P or S because their relationship is not very direct. We have to depend on the 15 or the 28,000. We have to depend on those numbers. So we're still going to set our change in price to be x. Okay, and we have to pick. We can either use the 15, 28,000 as a pair, or we can use the 12 or 34,000 as a pair. Just like in the previous example, we have to have a place to start. So R of x is going to be P of x times the unit of all the tickets sold, S of x. So let's say we are actually going to pick the first pair. They're going to give you the same result. Then that's going to be 15 plus x. So every single dollar it goes up is 2,000 less tickets. So in this case, if it's x dollar going up, it's going to correspond with 28,000 minus 2,000 x, because each dollar here corresponds with a negative 2,000 tickets sold. So there you go. There's our function. So that is going to be 420,000 plus 28,000x minus 30,000x minus 2,000x squared. Let's simplify. It's going to be negative 2,000x squared minus 2,000x, then plus 420,000. Okay, we are trying to maximize the revenue, which basically means we're trying to maximize this quadratic function. So we are going to need our negative b over 2a. So x is going to be negative b over 2a. That's what we're trying to find. So it's negative, my b is, so it's going to be negative of negative 2,000 over 2 times negative 2,000. And that is a negative 0.5. Well, that's the actually x value that's going to maximize our revenue. But the question is asking for a few different things. The question is asking the ticket price, the attendance, and the maximized revenue. So that means we need to find our P of x, our S of x, and R of x. So this is the x value that's going to maximize our revenue. Let's find the P of x, which is 15 plus x, which is 15 minus 0.5. So our ticket price is going to be at 14.5. Next, S of x. That is going to be 28,000 minus 2,000x. So it's going to be 28,000 minus 2,000 times a 0.5 is going to be 1,000, which means our ticket sold is going to be at 27,000. Then to find the Rx, you have two options. You can either plug in negative 0.5 into the original function, which is right here, or you can just use the 14.5 times the 27,000. Well, I just realized I actually had a mistake because this x is going to be a negative 0.5. So when you multiply, it's actually a plus 1,000, which means it's going to be 29,000 right here. So if you multiply these numbers, my revenue, my maximized revenue is going to be $420,500. There you go. That's example 1. It's a bit more complicated than example 2, just because you have to identify this information, this dollar change, and the ticket sold change corresponding to it to be able to set up the revenue. But after that, as soon as we found that, we can still use the change in price to set up our function. There's another way to actually solve this, which is actually find that relationship between the price change and the unit sold change. But that to me is a bit more complicated of a method. But this is a more general, since it could also be used for the other question that we just finished. Now let's go to example 3. The unit cost in dollars to produce bins of cat food is $13 and the fixed cost is $6,734. The price demand function is given. So this is actually the price. What quantity is the smallest break-even point? So here's a little hint. Find the cost function, revenue function, and then find the profit function. So let's quickly review. The profit actually is the revenue minus the cost. And break-even point basically means I need the revenue to be exactly the same as the cost, so I'm actually not making any profit. So that is the breaking point. So this is what we want. So just like the hint, in order to find the break-even point, we need the revenue function, we need the cost function. So let's go back to the first sentence to start setting up the cost function. The X here, well, is the demand, is the quantity. So to produce bins, each one is going to cost $13, and the fixed cost is just on top of that. So it's going to be 13x plus 6,734. That's the cost function. Next, revenue function is going to be the price function times the x, because x represents the amount, the quantity, or in other words, the unit sold. So we're going to have 269 minus 2x times x. Now we need the profit function, and then we need to set it equal to 0. So there you go. Well, let's simplify this. It's negative 2x squared plus 269x. So what I need is the revenue function subtracting the cost function. Negative 2x squared plus 269x. Subtracting my cost function is 13x plus 6,734. And we need that to equal to 0 so that we can solve that equation. So negative 2x squared plus 269x. This is minus 13x minus 6,734. So we got it plus 256x minus 6,734 equals 0. Clearly, there's a GCF. We can divide every single thing by a negative 2, which will give us x squared minus 128x plus 3,367. You can either use a quadratic formula or you can choose to factor. We need to find a combination of two numbers that multiply to get a 300,367 and adds up to a negative 128. These two numbers would be a 37 and a 91. So my x could either be 37 or x could be 91. And is asking what quantity is the smallest break-even point. So we found two answers. We need the smallest break-even point. So 37 is the smallest break-even point. And that is example 3. So this one is not as complicated as the other one, but you do need to understand the formula. Profit is revenue minus cost. And that is everything for this 4.14c lesson. Thank you.